All right, so first thing we're going to take a look at in 2.1 is on what we call zeros. It's also called roots of polynomial functions. And we talked a little bit about that. We did the discriminant yesterday at the beginning of class, at least for quadratics. Well, let's look at it for a cubic. So let's graph that equation and see how many times it crosses the x-axis. So we've got 2x cubed minus 3x squared minus 3x plus 2. I'm going to try zoom 6. If that doesn't work, I'll adjust. That's fine. So how many times does that graph cross the x-axis? Yeah, 3. It crosses 3 times. At each point where it crosses, what's the y value of the coordinate? Here, here, and there. Yeah, 0. So the y value of a point that crosses the x-axis is always 0. What's the x value? Well, that we don't know. We could try to figure that out. Now, what I wrote up above right there and what I have right there are exactly the same thing. I could prove it algebraically. Showing something graphically is never a proof. But I'm going to graph that on top of the original, and I'm going to show you that they look the same, which suggests they are the same. And they are. Okay? But the only way I could really prove to you they're the same is if I foiled that up. But I don't want to foil it out right now. So the blue one is going to stay on the screen, and I want you to watch what the red one looks like. Do they look similar? Yeah. Again, that proves nothing. It just suggests, okay, they probably are the same. Now I could foil this all out and prove it, and we did some foiling on the homework last night. Now, anybody know why you'd want to write it this way? This is factored compared to writing it foiled out. Why would you want to write it factored like this instead? Yeah? Yeah, it makes it extremely easy to find the zeros. I can tell you the zeros are -1, 1/2, and 2, just by looking at the factored version. Okay, how did I do that? Well, if you have something factored and you set it equal to 0, all you have to do to solve it is find the number that would make this come out to 0, that come out to 0, and that come out to 0. -1.5. 2. Now, if you couldn't factor it, we can use the calculator. And I'm going to show you how we can do it. If you go to second calc, there's an option there that will help us find where it crosses the x-axis. Which option do you think it is? Yeah, 0. The way 0 works is it asks you 3 questions. Pick a point that you know is to the left of where it crosses. Pick a point to the right, and then do a guess. So let's do this one all the way on the left. Pick a point that is somewhere to the left, and then hit enter. Pick a point somewhere to the right, hit enter. And now we've got 2 vertical lines that are kind of marking where we think it crosses, and it's going to look in between them once I do the guess. Just put the guess kind of close and see what it tells you. There's your 0. -1 is one of the x values you can plug in to get 0. Let me move this back. Okay. So, -1. And if I went through and found the other ones the same way, what do you think this one would be? 0.5, or 1/2. And the third number? 2. So you can see it. Sometimes it doesn't cross at a nice spot and you get a decimal. So you do have to calculate it. You kind of know it's those numbers because you have the factored version already. But if you didn't have that, the calculator would have been really helpful.
On a cubic equation like that, that +2 at the very end will be, will one of the zeros always be that value?
No. It's a good guess, but no. If I change it to something like a +3, and I clear out the other one because we don't need that anymore. So if I change it to +3, you're going to see it doesn't cross at 3. I hope. Still looks like it kind of crosses at 2. It might. I don't know for sure. I definitely messed up the 1/2. I can tell that. But I'm not sure about anything else. Yep. Yeah, we're going to do some more of those today. Yeah, we'll do some more. So if you find a number that you can plug into an equation, like here's a simple one. If you can find a number that you can fill in for x, and you get 0 for y, in this case, -2. That number, -2, 0, would be called an x-intercept. The number -2 itself is called the 0 of the equation. You can also call it a root. Depending on the type of polynomial, it can have more than one root. This is a linear polynomial. It only has one root. -2 is the only number you can plug in for x and get 0 for y. So linear is the easiest case because there's only one solution. And in general, could somebody tell me how you would get x by itself in that equation?
You would subtract by b and then divide both sides by a.
Yeah, you'd subtract the b, so you'd have a -b, and then you'd divide by a. And if you did that, you would have x by itself, and the answer that you get would be the root of the equation. I would say for linear equations, it's easier to solve it algebraically. When you get to quadratics, you've got quadratic formula. When you get to cubics, quartics, anything higher, if it's factorable, we can do it. If it's not factorable, then you have to use a calculator. But we're going to learn how to factor things like cubics. So like that first problem I did, by the end of either this chapter or the next, maybe it's the next chapter, you'll know how to factor something like that. Because all the answers were nice numbers, -1, 1/2, and maybe it was 2. You'll be able to factor that. All right, so let's solve this one for the root. Okay, that's a linear equation. It's the easiest type of equation to find a root for. What would you get when you solve for x there? Yeah.
X equals -2.
Yeah. So we have that formula, -b over a. Any question on that? Now, when we go up a degree, so we go from degree 1, which is linear, to a degree 2, which is quadratic, now the formula gets a little more complicated. It's not just -b over a. Now it's b squared, it's -b plus or minus the square root of b squared minus 4ac all over 2a. It gets a lot more complicated. It's the quadratic formula. Now, how many roots, or how many zeros can a quadratic have? Yeah?
0, 1, or 2.
Right, it can have 0, 1, or 2. Depends on what the parabola looks like. Now, we just talked about that yesterday. Remember, the discriminant is a quick way to tell how many roots you have, whether the discriminant comes out positive, negative, or 0. All right, we made a chart for that yesterday. Okay, so let's solve this. Since it says approximately, I'm okay with using the calculator. If it said solve exact, we would probably have to either try to factor it or use quadratic formula. Okay. If I wanted to type this in so that I can put all of it in y1, I need to get it equal to 0, just like we were going to factor it. So what could I type in on y1 if I get that equal to 0? Really?
Is it the square root of 1 minus 2x over 2? Make it 0.
So you're just going to put all the terms on one side. Yeah. Just get it equal to 0.
Okay, so negative 2x squared minus 3x.
Okay, you could do it that way. Negative 2x squared. Yep. And then what?
Minus 2x plus 1.
Minus 2x plus 1. I was thinking to move everything to the left side. I know that's more things you have to move, but then it keeps the squared term positive. I generally think that way just because of factoring. But that way works as well. Let's hit graph and see where we have. How many roots does it look like that one has? Yeah. 2. So we're going to do second calc 0. Okay, I'm going to do the one on the left. If someone else can do the one on the right, that would be helpful. So I need to move my cursor till I know it's to the left of that root. Hit enter. Move it until I know it's to the right of it. Hit enter. And now I've kind of trapped the root between those two lines. And then I'm going to move it close for the guess. So my first answer is negative 1.37.
Pretty sure we have a problem.
What's the...
If you
Yeah.
drag those two numbers to the left, the parabola is facing up. If you drag the other number to the right, it's facing down.
Correct. If you was opening up, it would look just like this.
They cross the same points but different.
Yeah, they'd have the same zeros. So you get the same answer either way. But yes, it's a very good point. It would face a different direction.
Yeah, they'd have two opposite ranges.
How about the other 0? Anybody get that one? Yep.
0.37.
Yeah, it looks like it's about a third of the way. I'd say that looks reasonable. So x is about 0.37. And you do it the same way. Okay. And anytime you see approximate, decimals are okay. Exact answer on that one, you're going to have to use quadratic formula and leave your answer as like, 2 plus or minus square root 5 over 7 or something. Whatever it would come out to. I just made that up. Okay, how do we find roots graphically? Well, I don't want you to write down this part. So finding roots graphically, and now I'm going to give you something to write down. So the method that we're going to use, it's not a better method, it is the method. The method that we use for finding roots is to use either the root or the 0 feature of the calculator, and that's what I've been showing you how to do. So that's how you find roots graphically. You go to second, I think I write it down. No, I don't. So it's where you press second, calc, and then it's option 2. Again, that only applies to my types of calculators. But that's how you do it. Now, this is a cubic. We don't even know a cubic formula. There is one, like the quadratic formula. It's very long, very, very, very long. Not just a little longer, it's like extremely long. So we're not going to learn the cubic formula in this class. I've never even learned it, period. We're just going to graph this and try to solve it approximately. So I want to do the same thing. Get it equal to 0, and then see where it crosses. Okay, what would I type in to get that equal to 0? Oh, Rory? So what would be the easiest way to make that equal to 0 instead of equal to 1? Subtract 1. So if you did that on both sides, tell me what would be on the left.
X cubed plus 2 squared minus
X cubed, can you say that again?
x cubed plus 2x minus 1.
2x minus 1. Yep. So anytime you're solving for roots, you get it equal to 0. Hit graph. And this is a cubic. We saw a cubic earlier. And the cubic we saw earlier crossed 3 times. That exponent is an upper limit on how many times it can cross. It's not a guarantee it'll cross that many times. It's just the limit. How many times does this one cross? Yeah. Yeah, it just crosses once. And that happens sometimes. So second calc. Sometimes I accidentally do intersect. You are not doing an intersect. You're calculating a 0. You could do an intersect if you drew in the line y equals 0. That would be right on the x-axis. Then you could find an intersect. But usually we just do it this way. So pick a point left, right, and do a guess.
And if you did the opposite of what you did to get the formula, the thing would be a mirror image, but the point that it stopped at would be the exact same.
The root would still be the same. Yep, but it would look more like a mirror image of it. So that's the 0. Generally, I'll ask you to go to like 2 decimal places or 3. So we'll say about 0.45. Any question on it? Okay, so this is called finding roots, and you'll have one like this on the test tomorrow. So 3rd degree polynomials, those are polynomials we call cubic. It means the highest exponent is a 3. And generally, these are the patterns you can get for cubics. The idea is one side always goes down, one side goes up. Down, up, down. Sometimes you see a curve where it comes back on itself and then goes up. That's how you can get the 3 roots. Sometimes the curve never really goes back on itself. It's just kind of a little bit of a bend, and then it just keeps going. The amount of the curve can change. So I mean, you could have something more like that. But that's still like that one right over there. Those are generally the patterns you can get for cubics. Sometimes these curves are more spread out, so you need to zoom out to see it. You may have a window on the calculator that looks like this, and your cubic might do something like this. Well, if you're just looking at that screen, all you're going to see on the screen is this. You might think it's a parabola, because that's the part you can see. You've got to zoom out enough so you can see the whole thing. And how do you know to zoom out? Well, you look at the highest exponent, and you have to know what a cubic would kind of look like. So you know what you're looking for. All right, so this question is just a how many. It's not asking us to solve it yet. First, how many solutions could it have? At most. Yep.
The most this can have is 3 because it's being cubed.
Yep, so it's a cubic. It could cross the x-axis up to 3 times, which means it takes 2 turns. That's how you cross 3 times. You turn twice.
It was power to 4. It has a possibility of 4.
Yeah, as you go higher in exponents, you get more possibilities that can happen. So the question is, how many solutions do we have? I don't think you need to zoom out to see it. It should be pretty clear. James, how many solutions do we have?
3.
3. Yep. It's going to cross the axis 3 times. Is there any question on how, if I said to you to find the middle one, or the left one, or the right one, how you do it on the calculator? We've done it a few times. I'm just wondering if anyone needs me to do it one more time. Yep, so one more time. So second, calc, 0. Pick a point that you know is to the left of your root. Hit enter. Pick a point that you know is to the right of your root. And then put your guess as close as you can. And it tells us the 0 is about 1.55. That's what I meant by the middle root. If you didn't know what I meant by middle and you had a graph, I would point to it and I'd say, well, I want to know this one. I wouldn't tell you how to do it. You have to know that for the test. Yeah. Sure. All right, so we got about 30 minutes left, and that'll be enough to finish the first part of this. So what did we say finding a complete graph means? What does that mean? When you look at the calculator, it means you... Yeah, everything that's important. So for a cubic, it means you can see the turns, if they do. If they don't turn, you can see the little curve in the middle. If it's a parabola, you're looking for the lower, the high point. So you can see everything that's important. So anytime that we solve a problem, usually, these are the 2 main methods we use to do every problem. You either make an equation to solve your problem, or you draw it out. That's what that's saying. So usually, solving a problem either involves making an equation or drawing a graph. Yeah?
Say something was only in like one quadrant, but it showed up in like the Zoom 6. Like, do I have to be more specific when I say my complete graph, or can I just say like the standard?
Well, it depends on what kind of graph it is. So if it's a line, I know it's just going to keep going forever and it's never going to do anything interesting. It's not like a line can all of a sudden go like this and then decide to, go like that over there. A line is just going to keep going. So if it was a cubic, though, and all you were looking at is quadrant 1, like let's say here's your graph, your calculator did something like this, and you just focus on this part for your window, I'd say that's not a good window for the cubic.
Say it was only in like one of them, not even like in like the whole thing, but just in one. If I said just like standard view, is that valid, or is that like not like specific enough? It's not like close enough.
So like if these are called local extrema, if those extrema were both in quadrant 1,
Yeah.
that would be okay. Yeah. So if your cubic did something like this, well, that's a little closer than I wanted it to be. Say, if your cubic looked like that, then yes, it would be okay to focus on quadrant 1.
Are we still writing?
Yes, I'm going to put it back. I just ran out of drawing. So this. I think the next question is the last one. So we'll see what we have time for. We'll either do one question or 2 questions. But I will tell you the next question is very important for the test. All right, so this question is going to be about an investment. And this person's going to has a total of $20,000 to invest, and they're going to split the investment between 2 different accounts. One account is going to pay 6.75% simple interest. The other account pays 8.6% simple interest. Now, obviously, it'd be better if you just put all the money in the account that pays higher interest. He'd make more. But maybe there's a reason he can't, for whatever reason. He has to split the $20,000 up between these 2 accounts. Now, you would need to know the formula for how simple interest works. I would tell you that, and I will tell you right now. Might have seen that formula, you might not have. It's not really how banks do interest, but it's a simpler formula than the real formula. It's close. And the formula for simple interest is I equals PRT. It has 4 variables. I stands for interest. P stands for the amount of money. That's called your principal. R is the rate that the account pays. Very important, though, that the rate is a decimal, not a percent. So if you have a percent, you need to change it. And T is the amount of time we're going to leave the money in the bank, usually measured in years. And it'll be a whole number. 1 year, 2 years, 10 years. It's not going to be like 13.4 years. I mean, it'll be a whole number. So I want to find an algebraic representation of the interest Bill earns in 1 year in total. How many different accounts is he investing in? 2. So I want to find the interest in the first account, take the interest in the second account, and if I want a total, I would take those 2 amounts and do what? Add them. Yep. Okay, we need a variable here, so we could use M for money, or we could just use X. Let's assume that he invests X dollars in the 6.75% account. How much is X? Well, we don't know. It's going to be X dollars. Yeah.
Do we know the rate of it?
Well, we know the rate of each account. Yes,
After
6.7.
how much time will it go up?
What's that?
Like, after how long? Like, would it be a month when it goes up? Or
Oh, I haven't given you a time. Well, yeah, I did give you a time right here. We're going to find the amount of interest that he earns in 1 year.
But that would be the total.
The total amount of time. Yes.
So does that interest keep going up every month?
We're going to assume that the interest is added on the last day of the year. So January through December, he doesn't make any interest, and December 31st hits, and all the interest gets put into his account. That's why I said this isn't realistic. Normally, a bank would add the interest every month, but then that would change your principal every month, because instead of you having just $100 in the bank, the next month you might have $100.13. So that would change our answer a little bit. So to simplify it, we'll just say the bank puts all the interest in the account on the last day of the year. That's why it's called simple interest. Simple. All right. So let's see if we can calculate the interest that Bill makes in the 6.75% account. So interest is principal times rate times time. Principal is how much is invested. How much money does Bill invest in the 6.75% account? Yeah? We don't know a number, but we do have a representation for it. X. So X dollars is the principal. What's the rate of 6.75%? Yeah. 0.0675, yes. Principal, rate, and what's the time that the money's going to be left in that account? Yep.
Why is it 0.06?
Yeah, I was wondering that as well.
Because to change percent to decimal, you move it 2 places to the left. No, 1 place would not be correct. 2 places. And what's the time? 1 year. So we don't even really need that. So the interest that Bill is going to make in the 6.75% account, if we write this kind of like a y equals mx plus b equation, it'd be 0.0675 x. Now that's not the only account. There's another account that he's going to earn interest in, and that's the 8.6% account. So let's find the interest that Bill earns there. Principal times rate times time. How much money does Bill invest in the 8.6% account? Yep. He invests X in the 6.75. Yep. X subtracted from 20,000. Perfect. He already invested X dollars. He has a total of 20,000. So 20,000 minus X is what he has left. Okay. What's my rate in the 8.6%? Yep.
0.086.
0.086. And the time, again, is the same. It's 1 year. So this one, we have a little bit more work to clean it up. We should distribute that 0.086 out. So 20,000. 20,000 times 0.086.
What's that?
Just a piece of metal, I think keys are changed. So 1720 minus 0.086x. I know that's not slope-intercept form. If you want to rewrite it with plus 1720 at the end, that's fine, but it's not necessary. Okay. So there's the interest at 6.75%. There's the interest at 8.6%. What do we do with those to find the total amount of money? Yeah, add them. So take the interest from the first account, 0.0675x. Take the interest from the second account, 1720 minus 0.086x. And add them up. So that's 0.0675 minus 0.086. So that gives me negative 0.0185 when you combine the x's. So that is the formula for the total interest. So now, if you told me how much money Bill invested at the, what was it? 6.75%, so he invested $1,300. I could fill $1,300 in for X, do it out, and I would automatically get how much interest he would make in total. I just need to plug in $1,300 for X. So that's our formula. In this part, they don't have us do anything with it. They just have us write the formula. Any questions on how we got the individual interest formulas or the total? No?
So it doesn't matter which interest rate you start with, right?
No, you could have let X be the amount invested in either percentage. It's just going to control what answer you get first when you plug in for it. Yeah. Yeah, you really could have done either one. They specifically said to let X be a certain one though, so you do have to do it the way they said to. Otherwise you'll get a little different formula. So we've kind of talked about this before. When you're doing a problem that's like a real life problem, what types of numbers sometimes you have to be careful about? Because they might not make sense. Is that? Yeah, sometimes negatives don't make sense. Sometimes decimals don't make sense. Like if you're buying, let's say you're buying like tickets for a concert. You can buy 5 tickets or 6 tickets. You can't buy 5.4 tickets. That doesn't make sense. So when we're graphing something, keep in mind the context of the problem and that certain values might not make sense. So now I'm going to tell you from that last one that Bill earned $1,509.10 in interest. That was the total. How much did he put in each account? Well, if they're giving me a formula, or they're giving me a number that involves the total interest he made, I need that formula that we just came up with. So what was our formula for the total interest? Yeah. 1,720. Okay, so there's the formula that calculates total interest, and it says Bill earned $1,509.10. Where would that $1,509 get plugged in? Check.
On the total interest side.
Right, this number is going to need to be plugged in right there. And then we don't really even need a graphing calculator to solve it. We could, but let's solve it. And if we forget, we'll go back and look at what X is. But remember, we are solving for X, which was the amount of money in a certain account. Okay, how would we solve that? What would be our first step? Well, yeah.
Subtract 1720 from both sides.
Sure. So subtract your 1720. So 1509.10 minus 1720. And you might think, well, this is a problem. We got a negative number, but what am I going to do next? I'm going to do what?
Get 0. Besides you have it.
Well, we're solving it algebraically. So we move the 1720 to the other side, and then you would.
Oh, divide by the negative 0.0.
Yeah, divide by the negative number, which is going to turn the answer positive because you don't want to get a negative amount of money. That wouldn't make sense. So divided by negative 0.0185. So Bill invested $11,400 in the X. Now what was X again? That was the amount of money in which account? Yeah.
6.75.
Okay, so that's the 6.75%. So then how much money is left? What was the other one? 8.7, 8.6? How much money is going into the 8.6% account? Yeah.
8,600.
Yeah, it's the difference of 20,000 in that number, which is 8,600. So just pay attention on the test which one it's asking for. If it's asking for both, there'll be a box on the test and they'll be labeled 6.75%, 8.6%. If it's only asking for one, then pay attention to which one it wants to know. Any question on that? Okay, so what I want to do is I want to put a list of topics on the board that are going to be on the test. So you got about 10 minutes. I'll have enough time to do that. And then if anybody has any questions, you can ask me about those topics.
Right there.